Hi guys, I'm Amir. Today I want to explain how can we configure Border Gateway Protocol or BGP. BGP is an exterior gateway protocol and creates connection between multiple autonomous systems on the internet, and BGP is the protocol that makes the internet work. And first I want to configure BGP basic configuration in the routers, and after that I should show you about one attribute, local preferences. First we should check interfaces. I have design and topology here. There are 3 routers in AS number 1 and 1 router R2 ES number 2 and R4, 3 and R5 are in AS number 3, and we have 3 autonomous systems that we want to make connection between them via BGP protocol. I should first check which interfaces we have in router 1, 2 or router 7. We have interface loopback 0, this one, and loopback 1, and interface 00 and interface 01, and we check there is nothing more. Okay, and about router 2 in AS number 2, we should check show running config which interfaces we have here: loopback 0, loopback 1, interface 00 and interface 01, and there is nothing more. About router 3, 4, 5, 6 and 7 are the same. We should start from router 1. Router 1 is located in autonomous system number 1. About autonomous system, internet is network of networks. It's broken into smaller networks known as autonomous system. About BGP, we should write router BGP, and router 1 located in AS1, and we should write here AS1. After that, we should make connection between neighbors. For router 1, we have 2 neighbors here, router 6 and router 7. This interface is a neighbor for router 1, and we should write here neighbor, and F00 interface's IP address is 1.0.0.2, and remote AS. Which remote AS? This is in AS number 1, and we should write here 1, and it means we have made connection between 2 routers in the same autonomous system. It means EIGRP. Another neighbor is for router 7, and router 7, F01 for router 7 is number 2, and remote AS is also 1. We don't have any more neighbor, and also we should define network in router 1, because router 1 want to advertise some network to another routers in the same AS and another AS, for example AS2 and AS3. Then we should write here network, and we have 4 network here. this network ID and mask, and we should write which mask we have here, /30. Yeah, this is subnet mask for /30, and another one is 70000 network, and another one is subnet mask. We have two subnet masks here, 10.0.1, and we should write here 5, because for loopback usually assign /32. Therefore, we should write here network 10.0.0.1 and mask is 255.255.255.255. And about another loopback is the same. Another thing, we should write here next hop self. What is next hop self? BGP protocol is AS by AS protocol, is not router by router protocol. When network enters from EBGP to another EBGP, EBGP means external border gateway protocol neighbor, we need to use this command for all of the edge routers because of changing next hop orders here. And we should write only in the edge routers like router 6, router 7, router 5, and router 3. Router 1 and router 4 are not edge router in this AS. We don't need to write next hop self command here. Only I should save. But exits. And another thing, in the AS that we have 2 or more routers, we should also configure IGP protocol. IGP protocol like OSPF, EIGRP, RIP, and ISIS, and yeah, something like that. It's essentially, you should write here. If you don't configure OSPF or EIGRP or RIP, your BGP doesn't work in this AS. You should write here router OSPF 1 and network 01001, and what is wildcard mask here? This is /30. Wildcard mask is 0003, and this is located in area 0. Another one is 700 for this network, for OSPF. And we can also write loopback. This is okay. We should write loopback here 10.0.0.1 and 0.0.0.0 wildcard mask for /32, and another is number 2. Exit. There is nothing more here. For router 6, we have 3 neighbor here, R1, R7, and R2. Also, there is no direct connection link between R6 and R7, but we should create virtual link here, and it is essential, and you should configure full mesh neighborship here. Router BGP number 1, because it's in the number 1, and neighbor, which neighbor we have here? 10.0.0.1, and remote AS number 1. Another one is 7.0.0.2. These interfaces, and it's in the remote AS number 1. And another neighbor here is F01 for router 2. And the interface is 2002. Remote AS is number 2 here. And we should advertise the network. Oh, another thing, yeah, I don't forget it. We should write for 3 neighbors here, for 2 neighbor, for R7 also next hop self. This is the command for next hop self. Okay? And also we can write for number 1 next hop self. There is I don't need to write for router number 2, only for EIGRP here. And network, which network we have here? 2 loopback, mask 255, 255, 255, and another thing is number 2 for loopback number 2, and network for 2000, and mask is 255, 255, 252, and another direct link here is number 1, and the same. It's okay. We should also configure OSPF router OSPF 1 and network. Which network we have here? Number 1. Excuse me. White car mask 3 and area 0. Another thing is there is I don't need here, only I have this network and 2 network here for loopback 60 number 001 and 0000, and for loopback number 2 also, loopback number 1 and IP address is 2. Do the WR and we should come out. And about router 7, this is here. We should write router BGP number 1 and neighbor. Which neighbor we have in 7? Router 7, this is F01 in R1, and IP address is number 1 and remote AS number 1, and about, and you can see the neighborship has been created and established, and also with R6 from this here, this interface, this is virtual link, this is 1002. Yeah, I want to be sure. And we have a neighborship with R3 in AS3 here, and this is RAS3, and what is the IP address here? 6002. We should write here 6002 2. And about next hop self, we should write for this interface, next hop self, next hop self. And about network, which network we should advertise via router 7000, and mask is 255.255.255.252, and we should also write here 600, yeah, this one, this network, and 2 loopback we have here. And for loopback we should write network 7001 mask 255.255.255.255, and number 2. Exit, and we should configure router OSPF 1 and network 7000, and we should write wildcard mask 3 and area 0. And you can see the neighborship has been established. Another one, network for loopback 01 and 770000, area 0, and number 2 for loopback number 1 in router 7. And you should write 2WR. If we face any problem, we should come back and troubleshooting. This is no problem with. If I write something here wrong, I can come back, and with troubleshooting we can find the solution. This is okay. This is okay. Now about AS3. We should start from R3. Router BGP number 3 and neighbor 5002 and remote AS number 3. Another neighbor is 4001 remote AS3 for R5, and in remote AS1 we have also 6001, this one. And next hop self for R5, next hop self command, and network we have 500 mask 255.255.255.252, and number 6 network. Another one is loopback 3001 mask 25, and this one. We should exit and write and configure router OSPF 3, router OSPF 3, and network we have 500 and wildcard mask 3 and area 0, Another one is network for loopback 30 01 000 area 0, and another loopback we should advertise with OSPF, this one. Do WR, and about number router R4 here, router BGP number 3 was neighbor 0101 with R5 and remote AS number 3. Another is 5, same remote AS number, and there is nothing more. And about network, one mask 255 255 255 255, and another loopback, another network 500, and mask 255 255 255 252, and another network, and exit router OSPF 3 also you should configure network, one area 0, and loopback numbers 2. Another network we have 4000 0003 area 0, and this is only and the same for network 5 to WR, and I can see some neighborship has been established, and for R5 and for router 5 we should write router BGP 3 neighbor 4002 remote 3 also, and another one is this IP address. This IP address is 5001. Yeah, 5001, and same IP address, same. Yeah. And another thing we should write here, and R5, another neighborship we should established here. This is 3001, and it's located in remote AS2. And next hop self, we should write next hop self for R3. This is R3 IP address interface. Next hop self. Yeah. And we should write network, which network we have here, 500 mask 255 255 255 252, and 3, and loopback 50001 mask 255 255 255 255 /32, also for loopback number 1 and network ID, yeah, here, and exit. We should configure router OSPF 1 also, excuse me, router OSPF 3, network 500, excuse me, 400 0 00003 and area 0 and loopback 0 1 0 0 0 0, and this is for our loopback. Do WR. The last router is R2. We should write here for R2 router BGP number 2, because AS number is 2 and we don't need to configure OSPF or other IGP protocols, only BGP. We should write neighbor. We have 2 neighbor here, 3002 and remote AS number 3, yes, and number 1 with 2001 2001, yeah, this is okay. And we don't need to next hop self, because we don't need next hop self in EBGP and EBGP connection. Only we should write in IBGP connection and configuration. We should also write network 200 and mask is 255.255.255.252, and number 3 for another network and another neighborship here. And now we can advertise these 2 networks ID from R2 to another. And loopback, should not forget loopback. 0 and mask is 5. And number 2 for another. I think this is okay. Yeah, there is nothing more. Okay, guys. Now we should check with verifying commands. Is there any neighborship has been created or not? We should write, for example, here in R1. You should write in R1 and okay. Show IP BGP summary. You can see all of the neighbor here. If there is any problem, we can do troubleshooting. You can see here we have 2 neighbor here, 1002 and 7002. And if you see up and down has any timer here, it means this is okay. And if, for example, here you can see idle in a state, it means you have any problem and you should do troubleshooting. No, we don't have any problem here. I can also check in R4 to make sure. Show IP BGP summary, and you can see there is nothing here idle and it's okay. And yeah, 6 minutes ago we have created this connection with 2 neighbor here, R5 and R3. And you can see in the R5, for example, also and show IP-BGP summary. We have 3 neighbor here. Also, we have 2 connection, but 3 because we have created virtual connection and virtual link with R3 and this interface 5001. This interface and this neighborship we have created, and this is essential because we want to prevent some problems in BGP configuration and split horizon rules. We should write it, and it means full mesh neighborship. Okay, guys. And another thing, for example, in R2, we want to check show IP-BGP. This command is about list of networks known by EGP. All of the network address. It's not best path or best routes. Only all of the networks. This router has been learned. You can see here 010 from 2 address and from 2 next hop and 200, 3004 and 567 and loopbacks are the loopbacks 10, 20, 30, 40 and 50, 60 and 70. Okay, you can see all of them here. Another thing we want to show you, show IP route. Yeah, and this is the best path, as you know, and all of the route that he has learned and selected as the best path. For example, here for reaching to 0400, this is here. Next hop is 3002, and for example 7000, and it has selected 2001 to reach R2 to R7. And the last thing we want to show you today, sometimes we want to change the path. I can show you in R4 show IP-BGP. Yeah, I can see anything I have forgotten here, and I should write for next hop cell for R4 in R5 and R3. In R3 I should write here, this is troubleshooting, because I want to show you what happened here. To reach, for example, 200, okay? This next hop is 3001, and this is next hop for R5. This is not for R4, and we should do some troubleshooting here. And we should write in R5 conf t and router BGP number 3, and I should find the IP address, the neighbor 4001. Yes. Next hop self and do WR, and also write also for R3 router BGP 3 and 5001 5002. Next hop self do WR, And also we should write for R1 here in R7 and R6. In R6 we should write exit router BGP number 1, and for R6 we should find 1001 command here, and next hop self do WR, and also for this one router BGP number 1, and we should find 7001. Next hop self. Okay, do WR. Okay, we should come back to R4. Before that, you can see here for reaching to 2000 here from R4 here you can see 3001 and 6001. Also the next hop is 4001 and 5001. And now you can see it has been changed. It is the miracle of next hop self. Okay, and yeah, this is troubleshooting. It's very good. Sometimes we can face some problems, and it's a good time to discover what is the problem and how to find this problem and how to find solution and something like that. And it was very good challenge. We have two routes for 200, 4001, 5001. I want to change the route because the best route now is here. Greater symbol show us the best way. The best way for 200 is now 5001. This is the best route, okay? I want to change it. In this situation, you should set some commands in R5. We want to explain about local preference attribute because there are a few attributes in BGP that help us to filter some networks or change the path. For example, in this situation, I want to change the path from R3 to R5. Now we should write router BGP 3 because it was AS3, and right here BGP default local preference. Local preference is by default 100. The greater and the higher local preference is to prefer. Okay, and we should write here, for example, 150. It's enough. And now we can come back to R5. R5, before that, it has changed and it has selected this route for reaching to this network. Now we should check. You can see that before that it was 5001 and now it's 4001 for 2000. Yeah, you can see here. Yeah, it's the operation of local preferences. There are so many settings you can set, but I wanted to show you only one operation and performance for attribute in BGP. Thank you for watching this video and see you later.